Okay, so let's discuss about the next service or the tool that can be used for the asynchronous communication, that is AWS SQS, that is Simple Queue Service. Okay, so here let's understand an overview of this SQS with a mind map. So here the first regarding the overview and function, it is completely managed by AWS. So here we do not need to manage the servers, like scaling and the management of the servers is completely done by AWS. So we just need to configure the queue on the AWS. So we'll look into that later in this video. Next, that will help us definitely in the asynchronous communication in the microservices architecture. And next, this will help in the decoupling the systems. So it's like the RabbitMQ, but there are a couple of major differences between RabbitMQ and SQS that we'll discuss next. But yeah, this will again help us in decoupling the system, where the service A and service B do not need to be in a continuous communication. Like they can be decoupled when we have a queue. So that can be done with the help of this simple queue, that is AWS SQS. Next, it stores the messages temporarily. So once the service or the consumer consumes the message gets deleted from the queue. Next, regarding the flow of the overall architecture. So here, as we know, the producer will produce the message, or it will send the message. That can be any of the service in the microservice, or it can be other AWS service like SNS. So that will send the message. Then that message will be sent to the queue. So here, unlike RabbitMQ, where we had exchange, then a binder and a queue, right? But here we do not have that concept. We just simply have a simple queue of two types that we'll discuss next, where the messages will be sent and it will be stored over there, and then the consumer will pull that message to consume it, right? So here, producer will produce the message. It will be stored in the queue. Consumer picks it and process it. And polling based retrieval, that means the consumer keeps polling the queue after in a regular interval for the messages. Okay, so when it has a message, it will receive it. Otherwise, it will just keep on polling for the new messages. So this overall flow allows the apps to continue running. Okay, next, the key characteristics here: no servers. As we discussed, it is fully managed by AWS, unlike RabbitMQ, where we need to create our own server, where we created the RabbitMQ server using a Docker container, and then we need to deploy it and to manage that, right? But here it will be, everything will be managed by AWS. It will scale automatically, unlike RabbitMQ, where we need to add multiple servers if needed, and also we need to manually add the queues and the binders. So that's not the case with SQS. So it will scale automatically, and it will make sure that at least once delivery, so that the messages are never left or they are never missed. They are delivered at least once. So that is made sure. So these are the key characteristics of SQS. Next comes the queue types. So in the queue types, as I said, there are two types. One is standard queue and one is first in, first out. So with the standard queue, we get a very high throughput, because here it doesn't need to manage the order. So it just needs to store the messages in the queue, and then it just get polled by the services. So with this, it gets a high throughput, and the high throughput is possible because of unordered message delivery. But if we go with the first in, first out type of a queue, then the messages are delivered in order, and exactly once delivery is assured here. And because of ordered delivery, the performance is a bit slower compared to the standard queue. And finally, the use cases are for the decoupling the microservices and handling the background task. Okay, so this is a simple overview of simple queue service. Next, let's look at the configuration of this over in AWS, and then we will just spin up a Spring Boot microservices, and we'll see how a message is produced and it is consumed. And post that, we'll discuss what's the difference between the RabbitMQ and SQS, and which should be preferred in which condition. Okay, so here right now I'm on the AWS console. So to create a queue, search for SQS, so Simple Queue Service. Here, click on Create Queue. And as we discussed here, we'll have two options. Either we can go with standard queue or first in, first out queue. So here, let's go with the standard queue, and just let's give a name as demo queue. Next, here we need to understand this configuration. Let's understand them one by one. The first one is a visibility timeout. So what does the visibility timeout defines here is, for that, let me just go back to this. So here, let's say this is the queue, okay? And once, let's say this message is coming from a producer. Okay, let's say there is a producer and there is a consumer. Okay, so the producer is going to produce the message, and that message will be sent inside this queue. So the moment it is sent here, the consumer will be keep on polling this. So the consumer thread will keep on polling, and it will just check that a message is there, and it will just try to get it, and it will try to process it. Okay. So the moment this message is sent over here, this consumer will have this much of time to process it. So for example, right now it's 30 seconds. So within that 30 seconds, this consumer needs to process this message, and it needs to send back an acknowledgement to the queue that this message can be deleted. Okay. So if within that 30 seconds, if that message was not consumed, then this message is again sent back inside the queue. Okay. So when the first time when the consumer has polled this message and it has got it, for that next 30 seconds, this message is not visible for any other consumers. If there are other threads that are polling to this queue for a message, then for those threads, this message will not be visible for that next 30 seconds because that has been sent to this consumer. Okay, and this consumer has 30 seconds to consume it. So if it doesn't consume that, or it doesn't process that message, then that message will be again sent back to the queue, and then it is again visible to the other consumers or the threads to poll it again and process it. I hope you were able to understand what is this configuration is doing here. That is visibility timeout. Here we can either set it in seconds, minutes, or hours, and maximum we can set it for 12 hours. So depending upon the kind of message, this can be set. Sometimes some kind of message that needs a larger amount of time to process it. So in that case, we can set a larger time here so that the message is not flushed back into the queue immediately. Okay, so I hope you were able to understand this first configuration. The next configuration here we have is the message retention period. So this is again like for how long the message can be there in a queue. So this will depend upon the speed at which the consumer is consuming the messages from a queue. So that can be between 1 minute to 14 days. So according to the requirement, we can just set this so that when the message arrived inside the queue, so it will stay there until a consumer is consumed for this period. Okay, so I hope this is clear and straightforward. Next we have delivery delay. So this is another property where once the message is arrived from a producer inside the queue, then here with the delivery delay, we are setting a period. For that period, this message is still not visible or available for the consumers to consume. So for example, if we set delivery delay as 5 seconds, then once the message has came inside the queue, now for the next 5 seconds, this message is still not visible for the consumer to consume. So only after 5 seconds, this message can be consumed or polled by the consumers. So that's regarding the delivery delay property. So for now, we can just set it to 0 because we don't have any such requirement where we want to put some delay for a message to be consumed. Next, we have maximum message size. So here it can be at max of 1 MB, that is 1024 KB. So that's we can set it between 1 KB to 1024 KB. And next we have receive message wait time. So what does this mean? So this property is with regards to the consumer. So how that is affecting here is once let's say this message is there, let's say there is only one message and the consumer has polled it for a message and it hasn't consumed. Okay, so once it has been consumed, then it will again poll for the next message. But now at this time the queue is empty, right? So now for how long the consumer can wait for a new message when it is empty, that is what we are going to set it over here. So if I say that it should wait for 5 seconds, then that means once the queue is empty, and in that case if the consumer polls, then if the queue is empty, then it will wait for 5 seconds and it will wait to check whether any new message will arrive. Okay, so if it is set to 0, then it will not wait for any time and it will just immediately get the response that the queue is empty. Okay, so I hope you got to understand what is this property. So here we'll set it to 0. So this is the overall configuration of this queue. And next we have the encryption. So Amazon SQS provides in-transit encryption by default. So we are enabling that. Server-side encryption is enabled. And for the encryption key type, we are going with Amazon SQS key. So the next thing here we have is access policy. So regarding the access policy, right now we have two options. One is basic and one is advanced. So in the basic, we have where we are defining who is the queue owner right now. So if it is your own account or if this account owned by your organization, then you can go with only the queue owner. But if you have multiple accounts or if you are accessing from multiple regions, then you need to change this settings for making sure that this queue is accessible outside of this region or outside of this account. So that's regarding the access policy. So this can be configured according to the requirement, and also you can go with the advanced configuration if the access is a bit more complicated. Okay, so for now here we'll go with the basic access policy. Next, redrive allow policy. So this is regarding the dead letter queue. So here first let's understand what is a dead letter queue. So for that, here, let's say this is a queue, original queue, where we are getting the messages. Okay. So let's say the consumer has consumed a message, but due to some issue, the consumer was unable to process this message. So what will happen after the visibility time out? This message is again pulled back or sent back to the queue. So this may happen again with some other consumer as well, right? So if that happens after multiple retries, then that message is sent to another queue that we can call it as a dead letter queue. So let's say this is a dead letter queue. So that message will be sent to the dead letter queue. So for that can be processed later on after resolving whatever the issue was there, right? So this is a basic concept of dead letter queue, where we do not want to miss any message to without any processing. So if there is some issue, then we will send that message to some other queue, which we call it as a dead letter queue, and later on we can just pull that message and resolve the error, and then we can consume or process that message. So that's the concept of dead letter queue. That is nothing but another queue. So now here we have the first property, that is redrive allow policy. What does this do? So this will make sure that this will identify which source queue can use this queue as the dead letter queue. So if you go to info, it will say that this is by default the redrive allow policy is disabled, which results in the same behavior as allowing all source queue to use this queue as a dead letter queue. Okay, but if we enable this, then we will have an option to allow only some queues that can use this current queue as a dead letter queue. Otherwise, if we keep it as disabled, then this queue, the current queue, can be used as a dead letter queue by some other queue. Okay, so for the time being, we'll just go with the disabled option. But if we do not want some other queue to use this as a dead letter queue, then we need to enable this and we need to configure the settings. But for time being, we'll just keep it as disabled. Next, regarding the same, regarding the dead letter queue, here we can set this queue to receive undelivered message. So for that, either we can make it as disabled, so we will not have any dead letter queue. But if we enable this, then here, first of all, we need to create another queue, and that we need to reference over here. Okay, and that will become a dead letter queue for this queue. And what is this maximum receives? So this is regarding the number of retries the consumer can do over a message. So if I set it as 2, then what does that mean? Once a message is there in the queue, and if it is unable to consume by the consumer, then in that case it will be sent back to the queue. So that's the first time it has been sent back. So if it happens again, then that's the second time. So that's the setting we are doing here. If it has been sent back for twice or 2 times, then that message is now available for the dead letter queue. So that will be sent to the dead letter queue. So that's the number of times we are setting over here. Okay, so that's regarding the dead letter queue. So right now we'll just keep it as disabled. We do not want to enable the dead letter queue. Next, coming to the tags, we can add a tag for this queue, and here finally we can click on create. So this will create a queue. Okay, and here we'll get an URL through which the producer can send a message to this queue. Okay, now to connect to this queue from the Spring Boot application, we need to have an access key and a secret key. So for that, you can go to IMA, that is Identity and Access Management, and here you can create a user with the access key and secret key. So for that, you can just go to users, and here you can just click on create user and give a name like SQS user, and just click on next. So here we'll not be adding it to any group, just directly we'll go to attach policies directly. So here search for SQS and give Amazon SQS full access as the policy attached to this user. Click on next and just click on create user. So this will create a user. Now for this user, we need to create an access key. Through that access key, we can configure that in our application, and we'll be able to access the SQS for this account. So create access key, and here we want to use this outside the AWS. So you can select this application running outside AWS, because the Spring Boot application is running on my local. So you plan to use this access key to authenticate workloads running in your data centers or other infrastructure outside of the AWS that needs to access your AWS resources. So here AWS SQS is an AWS resource, and my application is running outside of the AWS infrastructure, right? So you can go with this option, click on next, then just click on create access key. So we got the access key and secret key. We can just put that inside our Spring Boot application. So here now this is the Spring Boot application that I have created that will act as both producer and consumer. So in this application, the dependencies we need to add, the first of all is this Spring Cloud AWS Starter SQS with this version. So this will help this application to connect to SQS and we need the starter web to enable the container and to create the REST APIs. Okay, so these are the two dependencies we need to add. Next, in the configuration, we need to configure the Spring Cloud AWS credentials. So here we need to add that access key, and next we need to add the secret key. So I'll be deleting this after this video got created. So you can just create your own access key and secret key. That's it. And then we need to add the endpoint. So here you can get the endpoint, and you can just add it over here, right? So, and here also need to add the region. So I already added it, AP South 1. That's the current region where I have created this resource. Okay, so that's all we need to add here in the configuration. Now let me just give you a quick walkthrough of the application. So first here we'll have a controller that will receive the message which from the client, you can say, and then this message will be sent to the queue. So to send it to the queue, I have created a SQS template. So with this template, I can just use the send method, and the name of the queue I need to give. So this is the name of the queue and the message. So this will be sent. And next, we are using this application as a consumer as well. So I have created a consumer. So inside the consumer, we need to add a listener, and it needs to listen to which queue that we need to add it over here. That's a demo queue. And here it will be receiving that message and it will be reading it. Okay, so that's all. It's a very simple configuration. And we also have the SQS configuration where I have created a bean in this container class, that is SQS template. So this bean gets created at the application initialization, and that bean or the object will be used by the sender, like the producer, where I am using it over here. So this bean get created at the end when the application starts, and that bean I'm using to send the message. So that's a simple configuration I have did for both the producer and the consumer. Now if I start this application, okay, so the application started on 8080. So we can just access it over here. Okay, so I have already added it. So we have sent a message. So message sent, this is the first message to SQS. So now this message, I have sent it to our Spring Boot application as a client. Now that message will be received over here, and then it will be sent to the SQS over this queue. Okay, and from there we have created a consumer, and this application itself acting as a consumer, where we have added a listener that is listening to that message, and that's the reason here we have received it from the SQS. Where now what happens once the application will start, this application, as it is acting as a consumer, it's keep on polling to that queue at a regular interval. So whenever it sees a message, it will pull it and it will process that message. So this is how we have got the message, right? Now if let's say I just comment the code and rerun the application. Okay, so now I have restarted the application. Now we don't have consumer, right? So now in this case, if I just send a new message, this is the second message to SQS. Okay, so we have sent this message. So message has been received to the this server. The server has sent that message to the queue, but it has not been yet consumed. Okay, so in this case, we should be able to see this message inside the queue. Okay, so now if we go back to the queue, and if we go to send and receive message here, you will see that messages available right now is 1. So here we have an option to poll for the message. So what does that mean? When we poll for the message, then that message is temporarily available to view for that thread. Okay, so right now there is a message in the queue. When I click on poll for the message, and for a temporary moment, this UI will act as a consumer. This UI will be able to see that message. Okay, so this will be able to see, but now it has to be consumed, or it has to be processed, or it has to be deleted. If none of them happens, then after the visibility time, that message will again send back to the queue. Okay, so now if I just poll for a message, you will see that I immediately got a message from the queue. So here I can just read it. So this is the second message to SQS. Okay, so now if I just refresh this page after 30 seconds, then you'll see that this message will not be available here to read, because we have set the visibility time as 30 seconds. And after 30 seconds, it will be again sent back to the queue. So if I refresh this now, you will see that now again this consumer, which is the UI, will not have that message. Okay, so if I just again do a poll for a message, then again I got the message. Okay, so now within this time, if I uncomment this and rerun, then if the message is still with that first consumer, then here I will not be able to read it. Okay, so here you can see the application started, but it is unable to read it. But you will see after a couple of seconds, it will be able to read that message. So just wait for a few seconds. So the moment that message is sent back to the queue, See, we have got this message. Okay, so now if I go back and refresh this, you will see that this queue is empty, or this consumer do not have a message to read or process. So now if I again just poll for a message, then I will not have any, because the messages available in the queue are 0. Okay, so it's of no use. So I hope you are able to understand here how the SQS is configured and how it is used. Next, let's discuss a couple of more details regarding the SQS. Okay, so let's look at the superiority of the SQS over RabbitMQ, or in which conditions SQS should be preferred over RabbitMQ. For example, if we are considering an e-commerce order processing, then SQS has a more advantage over the RabbitMQ, because here we just need to process the orders from that e-commerce application, and here that can be done with one single queue, and we can process any number of orders even when there is a spike in the order placement, because of there we do not have to maintain any server. It auto scales and never loses a message. But what are the challenges with RabbitMQ? Like we need to set up the cluster, that is we need to scale manually, and that is a challenging process compared to the SQS. Next, for the background jobs for serverless apps, so serverless apps like Lambda, that is an AWS service, so that gives a native integration. We can natively integrate the Lambda with SQS, but that is not the case with RabbitMQ. So this will help us in scaling massively within a short span of time. But that's not the case with RabbitMQ. Next advantage is microservice communication in AWS native systems. For example, if we have deployed our services on EKS or ECS on AWS, then SQS is our best option compared to the RabbitMQ, because SQS act as another service within the AWS architecture. So that will help us to easily like broadcast messages within that architecture. But when we look at the RabbitMQ, that we need to set up separately. That will be outside of the core AWS architecture. So, and that also brings us with the routing complexity. But here it will be fully managed, having infinite throughput, and DLQs are inbuilt, as we discussed. DLQ here stands for delta queues, and simple no routing models. So if we have complex routing, then definitely RabbitMQ will help. That we'll discuss next. But if we have a simple application where we are concerned about very high scale, and if we are seeing a very high spike in the input or the request, in that case SQS will help, and that should be preferred. Next, for the large scale data processing pipelines, SQS have advantages like very high throughput, very cheap, and a simple queue model. But here it will be challenging, because it chokes at very high requests, as we has discussed. SQS is well suited for around 50k to 100k messages per second, but if it is more than that, then definitely SQS will help, because it will scale automatically and be able to handle the high load. And for the mobile app background workload, like SQS had an advantage where no server maintenance or handle unpredictable traffic spikes. So overall, these are the major advantages of going with SQS over RabbitMQ for some kind of scenarios. Okay, then now let's discuss about what are the advantages of RabbitMQ over SQS. So that will give us a complete picture. Okay, so here considering the RabbitMQ over SQS, the advantages are, like the first one is complex routing requirements. So RabbitMQ provides us with the routing feature where we can have the multiple exchanges and bindings that will help us to do a direct exchange where we can directly send the message to one queue, or a topic exchange where we can like send the message to multiple queues at the same time. And then we can also fan out the exchange. That means it's act as a publisher subscriber model, and this is possible because RabbitMQ acts works on a push based mechanism where the RabbitMQ pushes the message to the consumer. It's not like consumer is polling or pulling the messages. Okay, but these features are not available with the SQS because SQS doesn't provide us with routing and exchanges. Next, real-time push delivery. So here RabbitMQ, as I said, it pushes the messages immediately to the consumers. So SQS relies on polling, where the consumer needs to poll for the message, and this is very helpful for the applications like where we need instant notifications, or low latency event delivery, or real-time dashboards, or the game live game updates. So for these kind of applications, RabbitMQ will definitely help because it pushes the messages as soon as it gets it. Next, we have strong flow control for slow consumers. So this is a very important feature which is absent in case of SQS. That is, the RabbitMQ helps us in prefetch count, acknowledgement, and back pressure. So back pressure is like when the producer is sending too many messages where the RabbitMQ is unable to hold that because of out of memory issue, then in that case, the RabbitMQ can send a message or a warning to the producers that it has to slow down, or it has to send only these many messages for some point of time. And that can also be done for the consumer. So if the consumer can also tell the RabbitMQ that it unable to process the number of messages which it is sending in some point of time or in some interval. So it can handle the back pressure at both the ends. So this configuration can be done within the RabbitMQ, but that's not possible in the SQS. So it has very limited flow control. Next, the message priority. So here in the RabbitMQ provides us with the priority queue, where we can like define couple of messages as higher priority, and those messages will be delivered first than the lower priority. So this priority setting can be done in the RabbitMQ, but in case of SQS, it does not provide the priority, or it doesn't support this priority queues. Okay, so that's an important feature of the RabbitMQ. Next, we have critical message ordering. So RabbitMQ preserves the ordering, but SQS also has that feature, but it comes with lower throughput and higher cost. But RabbitMQ natively helps us to preserve the ordering. So these are the major features or advantages over the SQS for the RabbitMQ. But there is no such thing like it can replace SQS or SQS can replace RabbitMQ. So it completely depends on the use case. According to the use case, we can use both the services. So I hope this discussion make you clear between the RabbitMQ and SQS. Next, let's see the next service.